Guys, let's look at the industrial isolation of nitrogen from air by fractional distillation of liquid air. Okay, let's first look at the flow chart. Yes, that demonstrates this process in a simple way. First of all, okay, air is a mixture of gases. So the mixture of gases being air, it is usually first pushed, or it is usually first pumped into filters or purifiers. Yes, air is usually pumped into filters or the purifiers. Yeah, when air is pumped into the filters, of course, usually air has got dust particles as part of the air component. So when air is pumped into the filters, then dust particles, are removed by the filters or by the purifiers. And then from the filters, air is led into the absorption tower. From the filters, air is led into the absorption tower. It is led into the absorption tower. Within the absorption tower usually contains concentrated sodium hydroxide solution or concentrated potassium hydroxide solution. And these solutions in the absorption tower, they remove carbon dioxide gas. Now, so that air remains free of carbon dioxide gas. And from the absorption tower, air goes to the cooler at a temperature of -25 degrees Celsius. Yes, air from the absorption tower is led into the cooler. It is led into the cooler at -25 degrees Celsius. And then from the cooler, air is led into the compressor at 200 atmospheres, and we are going to discover how it is compressed at -200 degrees Celsius. Air is led into the compressor. We have got the compressor. We have the compressor. When air is led at the compressor, this happens at 200 atmospheres. This happens at 200 atmospheres. In other words, this happens at an atmospheric pressure of 200 atmospheres, and it is compressed at -200 degrees Celsius, the temperature of compression of air. Because in the compressor, air is compressed. We have got here in the compressor the expansion and the contraction of air, and this time it's liquid air. So I've got the expansion and contraction of liquid air during compression, and this takes place at negative 200 degrees Celsius. And what comes out of the compressor is liquid air. And liquid air is led into the fractional distillation chamber. We have got the fractional distillation chamber. We have the fractional distillation chamber, and from the fractional distillation chamber, within the fractional distillation chamber, liquid air is fractionally distilled, and we are going to discover here nitrogen, the fact that it has a lower boiling point, usually it comes out fast. Usually it vaporizes out fast. And nitrogen, it comes out at a temperature of negative 196 degrees Celsius. Then rare gases, they come out at a temperature of negative 186 degrees Celsius. Yes, this is nitrogen, which comes out at negative 196 degrees Celsius because it has a low boiling point, followed by rare gases. You can take argon as an example. And then lastly, what comes out lastly is oxygen gas. And oxygen gas, it comes out at a temperature of negative 183 degrees Celsius. 183 degrees Celsius. And this is oxygen gas. It comes out last. Let's note down some important points, to make us memorize this process in a much more accurate way.